Hello everyone. In this video, we will discuss our next topic of module 2, that is D'Alembert ratio test. Okay, and this is our lecture number 8 from module 2, that is lecture number 2.8. So let's start D'Alembert ratio test. Okay. D'Alembert ratio test, this is very important and very powerful test. Okay, first question is how to know that you have to apply D'Alembert ratio test. Same question I have told you in for comparison test, how to know you have to apply comparison test. Now same question for D'Alembert ratio test. So first, un will be in ratio format. Okay, un will be in ratio format. Okay, and number 2 is there will be no degree difference. No degree difference between numerator and denominator. Okay, so un will be in ratio format, and number 2 is there will be no degree difference between numerator and denominator. So question is, can we use D'Alembert ratio test if there is any degree difference between numerator and denominator? Answer is yes. If there is any degree difference, we can apply D'Alembert ratio test, but comparison test will be easier. Okay, so I will suggest you, if un is ratio form and there is a degree difference, use comparison test. Okay, yes, you can apply D'Alembert ratio test, but comparison test will be easier. Okay, and if there is no degree difference, so obviously you have to apply D'Alembert ratio test. So if there is no degree difference, you cannot apply comparison test. Clear? Okay, so let's start. D'Alembert's test. Summation, let summation un be a positive term series such that limit n tends to infinity un plus 1 divided by un, this is equals to L. Okay, limit n tends to infinity divided by un, this is equals to L, and L must be finite number. L must be finite number. Okay, so let summation un be a positive term series such that limit n tends to infinity un plus 1 by un, this is equals to L. What is un plus 1? What is un plus 1? Un plus 1 means n plus 1th term of the series un, and un means nth term of the series un. Okay, un plus 1, that means n plus 1th term. Okay, and un means nth term. Okay, now if this is equals to L is some finite number, then if L is less than 1, okay, if L is less than 1, then summation un is convergent. If L is less than 1, summation un is convergent. If L is greater than 1, summation un is divergent. Okay, and if L is equals to 1, test fails. Okay, suppose the limiting value, this L is greater than 1, then we can say the series will be divergent. Suppose L is less than 1, then the series will be convergent. Okay, and if L is equals to 1, then D'Alembert ratio test fails. then further we have to apply another test. Okay, we are not getting any conclusion from D'Alembert ratio test for L equals to 1. This is the statement. Let's solve using an example. Suppose question, test the convergence of the series summation n equals to 1 to infinity n factorial into 2 to the power n divided by n to the power n. Okay, n factorial into 2 to the power n divided by n to the power n. So this series in standard form, na, summation un form, in standard series form. So obviously this number is our un. So here solution, here un equals to n factorial into 2 to the power n divided by n to the power n. So what will be un plus 1? Just put n equals to n plus 1. Next number, so n plus 1 factorial into 2 to the power n plus 1 divided by n plus 1 to the power n plus 1. Okay, so this is our un plus 1, that means n plus 1th term. This is our un, that is nth term. Now calculate this one, limit n tends to infinity un plus 1 by un. So limit n tends to infinity un plus 1 divided by un, this is equals to limit n tends to infinity. What is un plus 1? N plus 1 factorial into 2 to the power n plus 1 divided by n plus 1 to the power n plus 1 divided by un. So un will be reverse, na? So this will be 2 to n to the power n divided by n factorial into 2 to the power n. Now simplify. This is equals to, I can write this in this form, that limit n tends to infinity. Let's take the factorial together. So n plus 1 factorial divided by n factorial into 2 to the power n plus 1 divided by 2 to the power n into n to the power n divided by n plus 1 whole to the power n plus 1. This is equals to limit n tends to infinity, you are getting n plus 1 into n factorial divided by n factorial into 2 to the power n plus 1, that means you can write 2 into 2 to the power n divided by 2 to the power n into, if I divide by n to the power n, okay, let me write, this is n to the power n divided by n plus 1 whole to the power n plus 1, that means n plus 1 into n plus 1 to the power n. Yes or no? Clear? So this is equals to, so from here n factorial cancelled, 2 to the power n, 2 to the power n cancelled, and also this n plus 1 and this n plus 1 cancelled. Okay, so what we are getting, limit n tends to infinity 2 into n to the power n divided by n plus 1 to the power n. Okay, now if I divide by n to the power n, so this will be limit n tends to infinity 2 into 1 by, this will be 1 plus 1 by n whole to the power n. Clear? Now what is the limit of this? So limit 2 by 1 plus 1 by n whole to the power n. What is the limit? Actually in class 11 or 12 you have learned 4 results. Limit n tends to infinity, let me use another color. Limit n tends to infinity 1 plus 1 by n whole to the power n, this is equals to e. Limit n tends to infinity 1 plus 1 by n whole to the power minus n, this is equals to 1 by e. Limit n tends to infinity 1 minus 1 by n whole to the power n, this is equals to again 1 by e. And limit n tends to infinity 1 minus 1 by n whole to the power minus n, this is equals to e. Clear? When the sign, this sign and this sign, the signs are same sign means the result will be e, and opposite sign, so result will be 1 by e. Okay, so let's come here. So limit n tends to infinity, so we can write this is equals to 2 by limit n tends to infinity 1 plus 1 by n whole to the power n, so obviously this is equals to 2 by e. Obviously this is equals to 2 by e. Now question is this 2 by e, this is less than 1 or greater than 1? The value of e is greater than 2 and less than 3, yes or no? The value of e is greater than 2, less than 3, that means that denominator is greater than the numerator, so obviously in that case this will be less than 1. Okay, and according to D'Alembert ratio test, and this is our L na, if L is less than 1 the series will be convergent. So by D'Alembert test, summation un is convergent. Clear? Summation un is convergent. Let's solve another problem. Question. Suppose test the convergence of the series 1 plus 2 square by 3 square into x plus 2 square into 4 square divided by 3 square into 5 square into x square plus 2 square 4 square 6 square divided by 3 square 5 square 7 square into x cube plus dot 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 x is not equals to 1. This condition is given that x is not equals to 1. The main point is you have to find out the un, that means the nth term. Okay, how to find out the un? Okay, solution. Un equals to, obviously you have to start from n equals to 1, because in my first lecture I have told you that series is the advanced concept of sequence, and in sequence domain is a natural number. Okay, so obviously you have to start from n equals to 1. Here you can see this is x, this is x square, this is x cube. So from this term you are getting n equals to 1, but what will be the this term, extra term 1? Actually all these terms is following a special pattern, but this term is not following the pattern. Okay, now remember, for infinite series you can ignore or you can neglect some finite number of terms. Okay, if any term is not satisfying or not following the pattern, then you can neglect the term, and it is possible only for infinite series. Okay, so we can neglect the first term. So write omitting the first term, omitting the first term. Now find out un is equals to, okay, so now this is our first term now, because we have omitted the this number. So now this is our n equals to 1, this is n equals to 2, and so on. Okay, so we have to think from this. Clear? Now when n equals to 1, here x is multiplied. N equals to 2, x square. N equals to 3, x cube. N equals to 4, x to the power 4. So n equals to n, x to the power n. So we have to multiply here x to the power n. It is clear. Okay. Now in first term it is containing only single number. In second term it is containing two numbers. In third term it is containing three numbers. So obviously in nth term it will contain n numbers. Yes or no? It will contain n numbers. So what will be the, now question is what will be the numbers? Now first numerator. Take a look on the numerator. First term 2 square. Second term 2 square 4 square. Third term 2 square 4 square 6 square. That means all the even numbers na. So what will be the n numbers? 2 square into 4 square into 6 square into dot 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 2n square. Now you have to verify it. Is it correct? Now when n equals to 1, you are getting 2 square. Yes, it is correct. When n equals to 2, n equals to 2 means 4 square. Yes or no? So yes, it is correct. The last digit is 4 square. Okay. Now when n equals to 3, n equals to 3 means 2 into 3, 6. 6 square. Yes, last digit is 6 square. So it is correct. Now denominator. N equals to 1, 3 square. N equals to 2, 3 square into 5 square. N equals to 3, 3 square, 5 square, 7 square. That means all the odd numbers. Okay. And the odd number starting from 3. So what will be the number? Obviously 2n plus 1. Because if 2n minus 1, so we have to start from 1. But here this is starting from 3. So 2n minus 1. Okay. So we have to write 3 square into 5 square into 7 square dot 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 2n minus 1 square. This is your un. Clear? This is your un. Now you can verify it. Put n equals to 1, n equals to 2, n equals to 3, and so on. Okay. Now apply D'Alembert ratio test. So obviously we have to calculate un plus 1. So this will be 2 square into 4 square into 6 square into dot 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 2n square. And what will be the next number? 2 increase na. So this will be 2n plus 2 whole square divided by 3 square 5 square 7 square dot 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 2n minus 1 square, and next number increase by 2. So this will be 2n plus 1 square. Okay. Now apply limit n tends to infinity un plus 1 divided by un. So this is this is x to the power n. So this will be x to the power, next number x to the power n plus 1. Okay. So limit n tends to infinity un plus 1 by un. So this will be limit n tends to infinity 2 square into 4 square into 6 square dot 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 2n square into 2n plus 2 square divided by 3 square 5 square 7 square dot 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 2n minus 1 square 2n plus 1 square. Okay. Into divided by un. So this will be reverse. 3 square into 5 square into 7 square dot 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 2n minus 1 whole square divided by 2 square 4 square 6 square 2n square into x to the power n plus 1 divided by xn. Okay, now you can see that all the numbers up to 2n square, all the numbers are cancelled. Up to 2n minus 1 square, all the numbers are cancelled. Okay, and here this is x to the power n plus 1 by x to the power n, so this will be cancelled and you will get x. So what is the next line? So limit n tends to infinity, so you are getting 2n plus 2 whole square divided by 2n plus 1 whole square into x, and this is equals to limit n tends to infinity. If I divide by n, so this will be 2 plus 2 by n whole square divided by 2 plus 1 by n whole square into x, and this is equals to, if n tends to infinity, you will get 2 square divided by 2 square into x. That means 2 square cancelled, x is the answer. Okay, that means this limit is x. But what is x? X is variable, na? We don't know the value of x. Okay, so what will be the answer? So you have to write by D'Alembert ratio test, if x, this is the limit, if x is less than 1, the series is convergent. Okay, if x is greater than 1, the series is divergent. Okay, and if x equals to 1, test fails. This is the final answer. Okay, so when x equals to 1, further we have to apply another test, and okay, and the test I will discuss in my next lecture. I think D'Alembert ratio test is very clear, and this is very important for your examination. Okay, so you have to practice all the question paper problems, okay, and all the textbook problems also. And if you have any doubt, please ask me. Thank you so much.